Hello everyone, today we are looking at lines on a graph. So we've talked about lines and line segments just normally, we've looked at their midpoints, we've calculated their lengths, we've talked about bisectors, we've done all sorts of things. What we're going to do is look at what they're like on what's called a Cartesian plane or a coordinate graph, if you want, kind of like our normal way of talking about it. So this is the line segment that we're going to be dealing with, and we're going to start by finding its slope. This might be a review, and that's totally fine, because the reason why we're reviewing it is it's a really important concept. The slope tells you the rate of change. In other words, how quick or how slow it's going somewhere. And it also tells you its movement. What that means is it's telling us how to get from point A to point B, quite literally. It's going to tell us the horizontal and the vertical movement that we take. In fact, what it's really going to point out is how far the point rose versus ran to get to the next point. So in order to get to B, I can see that I dropped a total of 6 units. You can just count them up, 1, 2, 3, 4, 5, 6, to get on level with B. And I have moved over horizontally a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 units. And since I'm going from left to right, that's considered a positive movement. We read these graphs like we do a book, left to right. And that's going to be giving me my general rate of change, or slope. And I can summarize it in a single number, because we really did this movement in one straight line like this. So we like to summarize it not in 2 separate numbers, but in one overall number. And that is determined by its rise over run. And since its rise is how far it went vertically, and its run is how far it went horizontally, my slope, or rise over run, is going to be equal to -6, the downward drop, and +12, the horizontal run. Of course, we like to simplify this. This should give us a -1/2, and it is nice to have slopes in a fraction form. And you can always check if you got the right one by simply checking if it gives you points on the line. So I can read this as the movement from A. I would drop 1, -1, and go 2 over to get to another point on the graph. And I could drop 1 and go 2 over to get to another point. And I could keep doing that, and it would always work, all the way until I get to B. So that will give me my slope. But we don't always want to have to count like I did over here. And sometimes we're only given the coordinates, we don't have the full graph, and making a whole graph just to do some counting seems like a waste of time. So we also have this formula. And what this formula is saying is, find the rise by discovering the change in y. So if I look at my point here, I'm at -5, 4 for A, and I am at +7, -2 for B. And if I want to find my rise, or my change in y, I'm going to look at my y values. Well, how far did I drop? I went from 4 to -2. So -2 minus 4 will end up giving us a -6, and that's my rise of -6. If I want to find my run, then I'm going to look at my x's, the change in x. How far did I move horizontally? Or what happened to my x values? Well, in that case, that's going to be 7 minus a -5, or 7 plus 5. And that gives me 12. So you see I get the same answer, which would of course be simplified to a -1/2. And that would end up being my slope. And I didn't even really have to do any counting. I just had to know where my coordinates were. Now, one thing to note here is it won't matter which one you pick as your x1, y1, and x2, y2. I could switch these around, and it would end up giving me the same final answer. But you just have to be careful that this is going to be one of your points. Like this is my x2, y2. In other words, this coordinate right here. And the other one, going straight down, my 4 and -5, is going to be my other coordinate, so x1, y1, which is this guy up here. And you have to watch that yours stays stacked like this, okay? If it's switched at all, it's going to give you a positive or negative slope where it should have been the opposite. So be careful there. You should always double check that your slopes are reasonable. So if I'm looking at slopes like these are just going to be some general slopes. There are a few rules that are just pretty constant. If your slope is going upwards from left to right, so as I move across the graph from left to right, am I going up and down? I'll be moving up, so that's going to be a positive slope. So you're going to see like slopes like 1 or 10 or 14 or anything positive there. Here, when we're going downwards from left to right, down is always a negative slope. So you might have like the -1, the -2, etc. Now, if you're not moving anywhere, you got someone just kind of like standing on this line as you go from left to right, they're not really doing anything. That right there is a 0 slope. You're not doing any vertical movement, and that's considered a 0 slope. If you're doing something like this, where as you're going from left to right, well, you don't even get to go from left to right, well, since you're not even moving from left to right, that's what we call undefined. An undefined slope isn't moving you across the graph, which is what slope is really telling you about. So those are going to pop up with equations like this. If you have x is equal to like -5, where you have the x equal to rather than y equal to, that's going to be the undefined. The 0 slope, in contrast, will still have a y equals, but it's not going to have any sort of x value in there. So this one will only have the y's. The last two ones here are really just to talk about a steep versus a shallow slope. So for instance, if I had a slope like this, where it's pretty extreme, like it's increasing pretty quickly, going up steeply, that is a large slope. In fact, this is a large positive slope. You can also have large negative slopes, and it's going to be close to the y-axis essentially, because it's going down very quickly, so that's the large slope as a negative. If you see something that is pretty close to horizontal, whether it's positive or negative, that is going to be a pretty small slope. So those would be numbers like 0.1x, or you might have m equal to 1/8. Something like that will be the small slope that gets you the slow rise or slow drop. And the large, of course, could be anything like 10 to 1,000. And the bigger it is, the steeper it will get, the closer it will get to that vertical line. Now, we still have more information to talk about. In particular, we have to talk about the midpoint and the distance formula. When we're talking about the midpoint formula, we're trying to figure out is what is the exact middle of this line segment. I can kind of estimate it just by looking that it'd be somewhere around here, right? It looks like it's about halfway between. But really what you want to find is what is going to be the average or halfway point for the x's, and what is going to be the halfway point for the y's, that these two things are equal and these two things are equal. And you can find that using this. Take your x coordinates, -5 and 7, and find the average between those two numbers. So my midpoint here is going to be equal to the average between my x values, -5 plus 7 divided by 2. And that will give me my new x coordinate. Well, -5 plus 7 is 2, and divided by 2 will give me an answer of 1. So I should be at 1, and look, my estimate's pretty stinking close to 1. And for my y coordinate, I want to find the average of my y coordinates. So I'm going to take 4 and -2. All over 2. And that's going to give me, well, that will be 4 plus -2 is 2, divided by 2 is also 1. So I end up with a midpoint that is at 1, 1. And you can see, like, even from my estimate, that looked pretty much spot on. Like, I was a little off with my estimating. But now I know it's exactly at 1, 1. Please watch out. The slope formula is going to have minus, as will the distance formula that we're using in just a moment. But midpoint is always going to use addition. And a lot of times we forget that just because we get in the habit of doing subtraction when we're doing coordinates. So please be careful. You're looking for the average, you need addition. And that does bring us to our distance formula. Well, distance formula is going to tell us how long this line is, or how long this line segment is from A to B. And that can be kind of hard to do without a ruler, and even on a graph, rulers aren't really that great to use because they might not line up with the distance between the boxes that you have. So what you're going to want to do is you're going to want to find the square root of the difference between your x value squared plus the difference between your y value squared. And later on in the year, we'll figure out how this formula is made, but for now, we're just going to practice using it. So I'm going to look at the distance formula using the coordinates that we have above. And I like to always start by writing out my formula so that I know what I'm substituting in with. I also know that my points that I have, x1, y1, is going to be equal to one of the 2 points on the graph. And I've been calling my first point the negative 5, 4. So I'm going to keep that going here. And then that means my x2, y2 is going to be my other point, 7, negative 2. And I'm going to have to be very careful substituting that I keep my x values as the first and my y values as the second. Well, now I can substitute in each of these values. So my distance is going to be equal to the square root of x2, 7, minus x1, which is a negative 5, so it's going to turn into a plus, and that's going to square, plus y2, which is a negative 2, minus y1, which is a 4, and again, I'm going to square that. Please watch out for order of operations here. You have to simplify inside the parentheses before you can take the square. So this is going to be 7 plus 5, or 12 squared, and 12 squared is 144. Negative 2 minus 4 is a negative 6, and negative 6 squared is a positive 36. Watch that you don't end up with a negative after you've squared it. If so, you haven't typed it into your calculator right. You always need parentheses around a negative, or your calculator will not read it correctly. At this point, I can just type that in, and that will give me my distance. So here, I have the square root of 144 plus 36, which is 13.416. And I don't really know what units I'm using, so I'm just going to write units instead. Please be careful when you're using this formula that you don't mix up your x's and y's, you don't forget that negative sign, and you really watch order of operations. If you're going to type this in one go into your calculator, that is fully possible, but watch your parentheses. You're going to need a second set of parentheses inside to do the parentheses 7 plus 5. Don't forget your squared, a lot of people do, plus that negative 2 minus 4, again, close parentheses and square it, and then close your parentheses overall, and that will give you the same one in one go. But there are a lot of little mistakes that people make, and it'd be really sad if you can get all this stuff written out right and you end up just typing it in wrong. So take care when you're doing that. I'd hate for you guys to go through all that work and end up with the wrong answer. All right, that is it for our lesson for today. The practice is in the book and posted online. Let me know if you have any questions. Hope you have a great day.